It's my pleasure to introduce Sven Arenz. Since 25 years research and for 12 years in BASF. And he will give a talk today about true instrument integration. Looking forward for your talk, Sven.
Thank you, Tobias. Hello, are you ready after the break? Perfect. So Tobias mentioned, I'm Sven Arenz. I'm with BASF since 12 years, but I have a challenging hobby since 25 years, and that is digitalization in chemical laboratories. Let's start. Don't be afraid. I don't talk you through all these facts and figures from BASF. One important point is BASF chemistry is used in almost all industries. Sven already mentioned it. And the problem is every industry has independent requirements, and that is even challenging for standardization. The good thing is I don't work for one or two of these fields. I work for all of them. I'm working in the analytics and material physics of BASF. Analytics means not data analytics, really chemical, physical analytics. So we analyzing materials. But all of these fields are aware that analytics creates a value for them. Which role does analytics play in BASF? So analytics is the key enabling platform along all business processes and value changes. We are the core of all knowledge-driven innovations. We drive efficiency and effective production processes, and in the end, we secure the license to operate. And the most important point, we are fundamental to the digital transformation. So what does this mean? I think you all agree we have one common goal. We would like to fully leverage the potential of our data, right? So we have all these nice tools, AI, machine learning, expert tools, user apps, and business intelligence tools. All these tools basically consume data. They may produce new data, but in principle, they would like to consume, or they need to consume data. So they need data, and where do this data come from? When I talk for the analytical laboratory, we think that our LIMS is the data center of our analytical laboratories. So our LIMS, the Laboratory Information Management System, basically compiles all the information, customer information, request information, and so on, and provides it via a data platform to these nice tools that we would like to use to leverage the potential of our data. But where do this data come from? And most of our data come from our instruments or lab data systems. So here, the data are really produced. The numbers are created. And that's why we think to fully leverage the potential of data, a sustainable and efficient integration of instrument is absolutely essential. So what does this mean for our analytical lab? We talk about 3,000 instruments, but not only 3,000 instruments of one type. We have 3,000 instruments, more than 500 models, and from more than 150 vendors. And these instruments produce data, and they need to be managed. That means they need to be collected, parsed, and processed. How do we do that? We use a LIMS provider, LabVantage, and the LabVantage company offers a tool called SDMS, so SDMS, Scientific Data Management System, and basically it's a toolbox. It provides the possibility to collect data from the instruments and then throw it in a pipeline, and then the pipeline does something with this data. So this toolbox is basically a file-based approach. So it's an indirect connection to the instruments. So it's a generic file interface, but that is a good thing. I'm using a file interface since 25 years to connect instruments to our system. It's a pity, but it's a stable, robust system, and we still use it a lot. Maybe in future it will change, I hope so, but it's still the best interface you can get to exchange data with instruments. But one thing that you don't get from LabVantage is the instrument-specific data parsing and processing logic. So you have to build them on your own. How do you do that? That was the offer from LabVantage, and basically every instrument provider nowadays provide the classic approach. That means they will develop individual, we call them attachment handler or parsers for each vendor and each format. So that means how they do it, you have individual projects for each file format, and you have individual risk. You do need to do a lot of testing, and not only if you run this in a GXP environment. In the end, you will have a lot of individual parsers. We did that for around 1 year. We were able to connect 5 instruments. Our target, 1,000 instruments. So 1/3 of our instrument we would like to connect within the project phase. So I think you don't need to be good in math that this curve will never hit the target. So that's why we discussed with LabVantage, guys, we need a generic approach. So we need generic attachment handlers for the generic formats like text, CSV, and XML that is mostly available by the instruments. And we need to be able to adjust these generic attachment handlers just by configuration. No coding, just configuration. And we improved. So after around again 1 year, we were able to connect 65 instruments. But we had still a lot of corner cases that needed individual parsers. And at this time and point, we again went in a coffee corner and start thinking. And we analyzed what we already had. And then we found out that all these parsers share a common processing logic. So more than 75% of the code is equal in all these parsers. So that's why we encapsulated the processing logic and developed individual parsers for individual formats. So we have a generic Excel parser, CSV, text, XML, JSON, and so on. And you just can combine this processing logic dynamically with the parser logic, and then can add the configuration for an individual use case. So basically, we could reuse the code, and we don't reinvent the wheel all the times. And by this approach, we were able nowadays to connect 676 instruments. So I think it's a bit off the theoretical curve, but that is, we are currently validating our system. So no, we have a lot of instruments in pipeline. But by this approach, we are pretty sure and optimistic that we reach our goal with 1,000 instruments connected in a project phase of 3 years. So that is what we have currently. But what is really needed for a sustainable integration of lab instruments? And Heiko already mentioned in the morning, we need 2 pieces. We need a communication and data. So that is the current or typical setup in our laboratories. We have an instrument and we have a LIMS system. We need some kind of interface. These interfaces need to communicate with each other, and the data need to be sent from the instrument to the LIMS or the way back if you have a bidirectional interface. So let's start with the communication. And here we have 2 prominent communication standards, LRDS OPC UA and SILA 2. But the communication protocol alone leaves us with a proprietary data structure, so we still have the data silos. When we talk about the data exchange, we need a data standard. So here we have, at least for us, we have three prominent candidates: allotrope, animal, and frictionless. But a data file or a data standard alone is not suitable for systems that cannot communicate with each other. So for sustainable integration of lab instruments, both are needed. Otherwise, you will not get an end-to-end integration of the lab instruments. So let's figure out what is the best communication and what is the best data standard, at least for us. We heard a lot about LIDS in the morning, and just summarized, LIDS creates a manufacturer-independent open standard for analytical laboratory equipment. And the good thing is, I don't know who was on the Analytical, but there are many German lab equipment vendors that already support LIDS OPC-UA. So that is one argument why we believe in that. The other thing is this supports existing lab data standards. And here I'm a favorite. I don't like this dependencies. If you take one standard, you have to use another standard. Here, in principle, you have the freedom to choose one communication standard and one data standard. Nevertheless, I think if two standards, when they team up, you will get more out of them at the end. It's good that they team up, so that we combine, for example, what you suggested, Heiko, LIDS with allotrope. But the most strong argument why we think LIDS is a good thing, we invited guys from the Spectari, so the LIDS people, to BASF. It was Matthias Arnold, Bruno, Jan, and Matthias Schuh. And we challenged them by a lot of BASF lab digitalization experts from different departments. And that was amazing. 2 days or less than 2 days. And we worked on topics like brownfield connectivity, future-proof device modeling, and even on the LIMS and STMS integration of lab equipment. And at the end of these 2 days, we found for all topics solutions. So that was amazing. How easy it is, how easy you can implement things when you work with standards. So absolutely amazing. Good. Communication, check. LIDS OPC-UA. How about the data standards? So, and here, Fred is not here. We had a small project in a couple of years ago to figure out what could be the best standard for a certain use case within BASF. So we looked on animal, allotrope, and frictionless. And the first question that we asked, which components of a complete data standard is needed? And we found the answer on the allotrope slide deck. So you need 3 parts. You need a context part, you need an ontology or controlled vocabulary, you need a taxonomy, and in the end an ontology. Without that, a data standard does not really make sense. Of course, you need data models for as blueprints so that you really can describe your lab items. And in the end, you need a suitable data format. So we were convinced that, or we checked the 3 parts against all standards, and we were very happy that we found all the things in the allotrope data standard. One thing that was still a question, or we had a question mark, that is on the file format. When we first looked in allotrope, there was only the RDF format. And the RDF format, together with a data model, I think it's pretty good for archiving. But we are talking about instrument integration. That means I have to work with this data. I have to efficiently and fast process this data. But when you release the ASM, the simple models, then it was again a strong argument for allotrope. Now we have a JSON representation of our data, of our lab data, and this is perfect for instrument integration. So now the future, let's say a Goldilocks scenario. We have everything. We have instruments that communicate via standard. We're exchanging data via the allotrope ASM format, but we still need to process the data in the LIMS system. But that could be, or maybe will be, our future LIMS data parsing pipeline. So we still have our processing logic. That will not change in future. We still have our generic JSON parser, so it's done. Why we shouldn't use it? Allotrope is a JSON, or the simple models are a JSON representation. But the good thing is we also have the JSON schema. And this JSON schema, it basically gives us a content parsing configuration. This schema tells you find the sample name there, and it's named like that. So perfect. So you don't even need to configure your handler. You get it from the schema. Another thing that you get from the schema, you can validate your data. So the instance of your data. So you directly see, yes, I got valid data from the instrument, or no, I didn't get. So in the end, sustainable integration of lab instruments requires standards. Unfortunately, that is the future. So it's not that we can set it up right now, but we still would like to start working with allotrope data. And there's one project, it's called Visual, and the mission is from instrument data to insights, so to leverage the full potential of data. And what would we like to do here is an intuitive visualization of big multidimensional instrument data with standardized and verified import from our LIMS to our data integration platform. LIMS provider, the Advantage, and Foundry is our data integration platform provider. So big dimensional data, I personally don't like this term. We talk about XY data. So we talk about XY data like force curves, rheology, IR data, but we have a lot of them. So we have hundreds of samples that we would like to compare. That is meant with big multidimensional instrument data. Unfortunately, on the instrument side, the data is only usable in the vendor software. Often we don't have integration or information about the LIMS, but nevertheless, again, we have the possibility to export our data, for example, for the first curve as an Excel export. And we're still struggling that different structures, even for the same instrument type, is found. And the data sets are too large to import the LIMS. The LIMS is good to have key value pairs, but if we talk about large XY data, LIMS is not very suitable to process or visualize the data. So that's why we are looking for a solution, how we can just visualize, plot this data. And that is an example from our data integration platform from Foundry. So basically, there have been done a lot of measurements, force curve measurements, and the customer or the people, the scientists in the laboratory, can just query, okay, I would like to see my samples from the last month, and then he gets the plot of all the first curve samples from the last month. And that works, or should work, seamless. So only the measurement is done in the LIMS, on the instrument, and then the data are available in our platform. And that's how we do that. We are already able to do that. So we use the LIMS setup that I showed before. We have our instruments. We use STMS. We use our parsing logic to parse the Excel data. But now we compile this data. We don't send the data directly back to the LIMS system, we compile them as ASM and write the ASM back to our LIMS. So now we have the Excel and the JSON ASM representation of our first curve data. This JSON is automatically transported to the data platform and can be read by our data integration platform. And our colleagues over there, they implemented a scalable adaptive visualization for ASM, not just force curves. So they are able to read all kinds of ASM data when they contain data cube or XY data. So, and that is in the end our first use case where we really can use ASM from end to end or to deliver an end-to-end solution. So let's come to the end. We believe that the standardization of interfaces in laboratory is the key to success for instrument connection at least. But we need a native support of a communication and a data standard by the data producer, so the instrument vendor, and the consumer like LIMS, ELNs, or even other vendors of software. Instrument vendors. You don't find a lot of instrument vendors that really support, for example, allotrope. So we spend a lot of efforts to convert our data. We heard yesterday we can use LLMs, we can use a conventional way or the classical way, but we spend a lot of effort to convert our data from the data that we get from the vendors to the data format that we need. On the other hand, we pay a lot for the instruments, so that doesn't sound like a win-win situation. So here, that comes to my my point in the morning. I really wish that with the allotrope future business model, we should also address vendors more, and not only that vendors say, yes, I'm looking in that, and it's a good thing, but they basically sit at the Seitenlinie at the corner and wait for the opportunity. No, then they need to proactive provide us the data in ASM like Edgeland, for example, already does. Good. Thank you very much.